Hello, this is the 921 Museum, Earthquake Museum in Taiwan. Okay, to start with, I would like to introduce the geography of Taiwan first. Okay, then I'm in Taichung right now, Taichung. Okay, which is stand for the middle area of Taiwan. Okay, but actually it's a bit north. Okay, in terms of the whole Taiwan. And then yeah, to start with, I would like to introduce the geography of Taiwan, and then yeah, it's like this. Okay, in the central there's a lot of mountain. Okay, it can be regarded as a flow mountain. Okay, and then well, they are really, they can say how say, they are having a flow mountain and then with valley. Okay, so it is proved that the faulting and also flooding is widespread. Okay, because why I'm speaking like this, because I mistaken this one is the East African Valley. Okay, with valley I want to kill it about it, but actually it's not, just East with valley. Okay, then this is a coastal mountain, and then yeah, let's see. Okay, there's a lot of mountain which is talking about the flow mountain in Taiwan. Okay, then yeah, it is really long. Okay, 340 kilometer. Okay, then this is somehow this flow mountain is very important, the ridge mountain of Taiwan, because Taichung is in this area. Taichung is in this area. Then it's gonna in Taichung is relatively drier. Why? Because the flow mountain have blocked the maritime current from the Pacific Ocean. Okay, then yeah, you can see there's different type of mountain that you can find in the flow mountain of Taiwan. Okay, for example, the Chi Lai Peak. I don't know 北大湖山. Okay, Su Yu Mountain. Okay, and then yeah, all the tall mountain. Okay, this is the second highest mountain in the Taiwan. Okay, and then this one J Mountain is the tallest, 3,900 something. Okay, then yeah, so it make up why the geography of Taiwan as well. This is also very preliminary plate boundary movement that making the volcanoes and also the earthquake and also the tsunami and also different kinds of landfall. I think you know what happened here, which is the formation of flow mountain. You can see right here, low subduction at all. So for the East African Rift Valley, okay, it is called divergent magma current and divergent plate movement. Okay, and then if there are which slab pool mechanism, then it create a large pressure in the plate boundary, and then if there are large pressure in the plate boundary, the magma are forced to rise up. Then it may form the volcanic island. Okay, depends on the situation. If it's just in the continent, then it may not have the island, but we are going it's also have island. Okay, because the ocean, we could just call it volcanic arc. Okay, then mid-ocean region and then trend may also occur. Okay, don't mix up, because in 2024 question is asking about flow mountain, but some of the students mistaken as the trench. Okay, two different things. Okay, flow mountain is on the mountain, is in the continent. Okay, ocean trench is in the ocean. Okay, then okay, Iceland is caused by the constructive plate movement, seafloor spreading. Okay, divergent magma current, divergent plate movement, plate moving apart from each other, and then the magma leaks out from the Line of Venus or the plate boundary, and then it is going to form a mid-ocean ridge when it is after the magma have been cooled and solidified repeatedly. Okay, then conservative plate boundary, which is the transform plate boundary. Okay, then yeah, this one I think you should know. Okay, then for Taiwan, I would like to talk about Taiwan geography again. Okay, So Taiwan is here, then it is also in the Philippine sea plate collide with the Eurasian plate. Okay, bear in mind, Philippines is not in the Philippine sea plate. It is in the Eurasian plate. Philippines is the volcanic island caused by the Philippine sea plate with the collision between the Philippine sea plate with the Eurasian plate. And also Taiwan is having similar mechanism, so you can see right here. Okay, and indeed Taiwan also having some volcanic island and also the volcanoes. Okay, I just know that the 龜山島. Okay, I found out the English later. Okay, I don't know what is the 龜山島 English name. Okay, but anyway, I show it in my looks explanatory video part lah. Okay, but right here we are also having in Taiwan. We are also having volcanoes. Okay, not just Taiwan, Philippines, and also Japan. They are somehow having similar plate boundary action. So next time when you are talking about the Asian part of the Pacific Ring of Fire, especially Japan and Taiwan and also Philippines, you can talk about Philippines moving towards to the Eurasian plate. Okay. And also you're gonna be careful about it is rather having maybe you are having a misconception for those destructive plate boundary that all of them are reverse fault, but actually it's not. Right here it's talking about Taiwan. This one in Chinese is talking about strike slip faults. Okay, which is in Chohyang. I don't know where is it. Okay, but how about this? The one that we are having a look right now. Where's the museum? Okay, it's also the reverse fault. Okay, it's quite long, and then it is for 38 kilometers. Okay, 60 kilometers. Okay, then there's a lot of different kind of faults as well in Taiwan. Okay, but most of them are strike slip. Most of them are reverse faults. Yeah, but some of them like this one, yeah, it can be strike slip faults. Okay, because it's the Taiwan itself, it is having different kinds of rock, and then the direction of the force exerted to the ground and exerted to the crust is not the same. Okay, then altogether in we can find out that in Taiwan we are having 36 active faults. Okay, 36 active faults. Okay, most of them are found in 10,000 years ago or even 100 years ago. Okay, 100,000 years ago. So you can see the impact of the earthquake. Need to wait 20 minutes indeed. It's finally getting back. Okay, so if we are going to have earthquake, although it looks like not really horrible, but indeed, even though the earthquake for 1 meters, okay, the height of the earthquake of 1 meters is going to giving a very strong situation already. Okay, for 100 cm, the mortality rate is already 100%. Okay, because it's quite strong already. Okay, 70%, all males will be swept away. Okay, so you can see it is we cannot neglect the impact of the tsunami since it's very fast. Okay, although right here not really fast, but indeed it's like a jet plane. Okay, then you gonna be very careful about tsunami as well. Okay, and this is the situation of the 921 earthquake, but most of you didn't born, I think. Okay, because if you are born, you are already 24 years old. Okay, then it is a you can see it is if you know Chinese, okay, it's happened in 1:47 a.m. and then the Richter scale is quite high, and then 7.3, and then there's a lot of injury, and then 2,400 people was dead, and then 39 people was missing. Okay, then so this museum is going to say preserve a floating area inside right here. So I'm going to show you later then, but this one is the good examples of how the earthquake taking place. So this is the fault line of the 921 earthquake, and how to call it, or Chalongpu fault. Okay, Chalongpu fault. And then this is a fault line which is extending the for 100 km length. Okay, you can see it's just part of the fault line, and you can see right here there's a sand accumulation. Then this one is already a fault line. But how come we can prove that the sand is already the fault line? Is because you can look at the upstairs. Okay, it's about different kinds of rock in there, but right here a lot of sediment have been deposited and accumulated right here, which is talking about right here. You can see the flooding is occurring, and also air shape right here. First, this formation associated with the faulting expressed, and there's around 30 meters high sand layer, okay, causing the profile. And the sand layer was originally like a banana sheet, and then now folded and into an S shape. Okay, then it is uplifted, and also the whole is saying that the whole school, okay, the playground of the school have been uplifted for how many meters? 1.62 meters right here. Okay, 1.62 meters. Okay, then it is quite high, and also not just 1.62 meters, just part of the playground. Some of them even have been elevated for 2 meters. Then it is a shell. Okay, then the accumulation of during that time earthquake is formed as a shell. Okay, compressed and formed a shell. Okay, if we can predict the the occurrence of the fault line, and also their uplift, the upward displacement of this kind of fault line, then maybe we can have a proper prediction of earthquake. Okay, so you can see, let's have a closer look. Okay, this one is not important because it's just about the human debris. You can see the construction, the collapse of the building. But right here, this kind of sand layer is almost like a rock. We call it shell. Okay, shell, 葉岩即係咁then it is going to be showing that there's a strong compression in between the rock layer. Okay, then the sand layer have been compressed and form a rock-like pattern. Okay， 咁佢會壓到好似變咗由沙變咗嚿石咁樣，咁咧就係咯。咁 this is the evidence of the faulting and compression taking place on there. Okay, it's also is the warning track again, and this warning track is also in terms of the earthquake prediction is quite famous. Okay, because it's well captured for the whole faulting. Okay, this warning track. Okay, then you can see some of them is raising for 2.87 meters height. Okay, and then some of them even horizontally is also being moved for 3 meters. Okay, then it is going to having a lot of research, and then you can have a lot of evidence that is going to help to see why the earthquake, how the earthquake have affected us. It is a very general aerial picture that after and before the earthquake. This is the area next to the museum, okay, 921 museum, okay, which is before the 921 earthquake. But right now, it's gonna be like this. Okay, a lot of building have been collapsed, and then this is as you have seen, is part of the aerial footage, and also you can see most of the building have been collapsed, so you can see how hazardous is it. Okay, this one is taken by a very famous photographer, indeed, Cp1. Okay, but he's already dead already because of a air tragedy. Okay, then yeah, you can see again after it was built, and then the rehabilitation process is keep going, and then right now it's becoming okay until 2014. And this one is one of the mountain next to this area. Okay, then it's the mountain, but after it there's a lot of rockfall and landslide. Okay, because right now even the earthquake is keep happening in the Taiwan, and then it is quite frustrating every day. Okay, because just like previously, in Hualien, which is in the eastern part of Taiwan. Okay, eastern coast of Taiwan, there's an earthquake. Then originally I want to go to the清水斷崖, which is a cliff next to the Hualien, and it's also being closed. The whole train station have been closed because of the earthquake. Then you can see right here, it is becoming like this, and then this is also the landslide caused by the earthquake, and then yeah, they keep fixing it, but and then finally the mountain, the vegetation is coming back, so on and so forth. And also this one is quite funny. It's a island in the lake. Okay, 日月潭. Okay, Sun Moon Lake. Okay, it's one of the island in the Sun Moon Lake, but it's 1997. Okay, but after 1999, okay, it's totally uplifted. It's uplifted. Okay, you can see the whole island is uplifted. Then it is talking about how the fortnight have been raised up in Taiwan. Okay, and also right now it is fixed to here. Okay, because the original one they don't want to build the same thing like this one. Okay, this is the 2008 footage, and then you can see, oh, they are going to build another kinds of thing. Okay, giving more coastal habitat for the birds, and then yeah, the middle one is originally this one, and then they may left it as a as the wounds and also the memorial site. Okay, for the monument site for the earthquake. Okay, so yeah, this is how the earthquake have changed our life. Okay, then let's move to the faulting. Okay, then yeah, it is a lot of faulting in Taiwan. Indeed, a lot of fault. Okay, I'm not going to ask you to remember all of it. Okay, but at least this one, okay, is where the museum happening, 車龍鋪. Okay, 車龍鋪. Okay, geologically sensitive site. Okay, it's quite important because it is rising up so much. Okay, and this area is really going to next to the central mountain. Okay, it's the extension of the mountain of Taiwan. The full mountain of Taiwan is like here. Okay, but it's extending. Okay, because Taichung, those cities of Taichung, cities of Taipei is here, and then it's in the coastal area. Then the fault is in between the mountain and the city. Okay, then it is going to be having a lot of fortnight. Okay, then you can see a lot of fortnight here. Then let's see. And also they have found out that it is having a lot of correlation between the fortnight and also the fatal rate of the fatality rate of the earthquake. Okay, if it's next to it, then distance from the fault, can you see? There are many people dying. Okay, then so if we are going to measure the fortnight, predict the movement of the fortnight more properly, then it may help to reduce the fatality rate. Okay, you can see, oh, in between 100 meters of the fortnight, the fatality rate is very high. Okay, and then if we are going to do more land use planning, okay, right here we are going to reduce the building density or build not allowing any kinds of development or just build it like the museum because even die, Mr. Leung is dying right now, okay? Then it's not really going to happen so much, and then there's a lot of building will collapse as well, okay? Then you can see the change of the fortnight, okay? Originally like this, and then it's becoming like this and like this, okay? It's the development of the collapsing of the road, collapsing of the farmland, and then the houses, so on and so forth. And also right here you can see there's a lot of it's originally the playground of the school, okay? It's the remainder, okay? It's the wounds of the playground. You can see the warning track, okay? Then it's totally collapsed, and then the whole it's reflecting the damage caused by the earthquake, okay? And it's the warning track exactly talking about the former one I've just showed you, okay? You can see there's a quick fault line right here, and then the dike that I just showed you is right here. Then you can see the whole warning track is breakdown, okay? Then it's even as tall as this, okay? I've just showed you, okay, indeed, but you can see how tall it has been upraised while compared with a human being, okay? Then yeah, all the school was gone, and then the road becoming this, and again the running track, half of the classroom was ruined, and then the playground have been uplifted for 2 meters. Okay. Again, how faulting create the earthquake, or how plate movement affect the earthquake. Okay, you should know the 5 steps, right? I keep telling you. Then sadly, this monitor is out of order, so I cannot show you the animation. But you can see right here. This is talking about Philippine plates. Okay, this is talking about Eurasian plates. They are moving towards each other, and then the stress accumulated, then maybe throughout the plate movement process there will be some volcanic eruption, or even the meteorite impact, 即係啲隕石跌落嚟 ，OK but anyway, the stress is mostly due to the plate movement, OK then the plate when the stress is larger than the strength of the rock, okay, beyond its elastic limit, but don't write this because maybe the marker in Hong Kong don't know, okay, bear in mind the stress larger than the strength of rock, okay, then the broken pieces ribate, okay, releasing the energy, and then was stored due to distortion, okay, which is the plate movement, okay. The earth crust is like a piece of metal, and then deformed by the external force, and it is going to accumulate energy accordingly. Then but once it is exceeding the elastic limit, then it will rebound in terms of the and resulting the dislocation. The released energy is transmitted to the surface by and then seismic wave vibration. Then we will call it as earthquake. That you should know. This is a very famous MC question. Okay, then what are the reverse faults? And reverse fault is hard to see. Reverse fault, okay, and then strike slip fault, and then the normal fault. So don't ask me again how to identify. OK， 講好多次啦，分開是正常。OK，if we break up, it is normal. Then if we are talking about normal fault here we go. It's gonna be like this. OK, they are moving apart from each other, and then they are separating one more time. Moving apart from each other, and then this block slide down. Normal fault. How about strike slip fault? Okay, this one is easy, okay, because they are moving, having the different direction. The force is having different direction, okay. Then strike slip fault. Okay, one more time. Okay, and then the reverse fault, actually they are moving towards each other, having compassional force, and then moving towards each other, then this block rising up, okay, this block rising up, then it's a reverse fault, okay. Then 記住啦，唔好再錯啦。Place move towards each other, reverse fault. Okay, these two is too mixing 嘅 okay, too confusing 嘅 okay, normal fault moving apart from each other, tensional faults are paired. Okay, one of the DBQ that will talk about rather the earthquake is what are the impact of the earthquake if it is next to the epicenter. Okay, the stronger the seismic intensity like this. Let me change to my right hand because my right hand is stronger. Okay, you can see this one will going to upside down first. Then it's talking about if we are next to the epicenter, then the seismic wave intensity is stronger. Mr. Leung is too light at this time, but anyway, then it's also talking about the distance will affect the intensity of the impact. Okay. So formally, they are this school is built on the fault line. Okay, and then there's a big fault line in here. Okay, indeed. So it is going to have a lot of vibration and also a lot of moving, and then the uplift of the whole school. Okay, so originally this is the original photo, but right now it becomes this. Okay, and then yeah, it is going to increase the whole area, the whole fault line have been increased from 0.5 to 9.8 meters. This fault line extended for 100 meters. So it's also showing how land use planning is important for here. Okay, for avoiding the very serious damage of the building. Okay, then you can see originally they are happily having a school like this, and then but sadly right here is exactly the fault line. Okay, and you can see the fault line is here. Okay, but it's not really clear. Okay, but they came. This is the 車窿浦fault. Okay, exactly right under us. Okay, then it is you can see the results of the earthquake is very hazardous. Okay, you can imagine how many people will get injured or even die because of this kind of earthquake. If the land use planning is no good and we are not going to investigate where is the fault line and then we build on the fault line, okay, then it will total loss. Okay, so you can see the school. Okay, so accordingly land use planning is quite important. Okay, then right now the new school, although it's just next to us, okay, it's right behind. Okay, next to the river, then it is not that it's not really exactly on the fault line. Then I think somehow it can we're going to reduce the damage of the earthquake somehow. Okay, so it is the ruins of the classroom that's happening in the Taichung earthquake previously. Okay, 921 earthquake. Then yeah, you can see it's totally the whole structure right now it needs to be supported by the metal frame. Okay, by the steel frame, and also the building structure that can be reinforced. Like this one is mostly in Hong Kong. Okay, the Thai bar is not that dense. Okay, but if we put this is originally happening in Hong Kong, right? The building, the Thai bar of the building like this, right? But it is no good. Okay, poor use. Okay, but in Taiwan they mostly put more Thai bar right here. Then this one is good. So to combating the earthquake, the impact of the earthquake, then we may going to have different kinds of measure that may help to decrease the vulnerability of the earthquake. Then you can see right here, there's a lot of metal frame. Okay, will be installed in underneath the bridge. Okay, they regarded as the anti-collapse device and also steel plate pillar reinforcement. Okay, then how is this going to help? Let's see. And also maybe there are some seismic resistant technology of the bridge. Then it is going to they may also install some optic fiber, okay, to monitor the collapse of the or the minor deflection of the bridge. Okay, it's also widely used in the high-speed rail in Taiwan. Okay, then if we are going to find out, oh, it is going to have deflects, then we can ask the people do the repairing immediately. Okay, and also the nuclear earthquake, how to prevent it. Okay, the nuclear is in Taiwan. It is built on the less active area of earthquake. You can see the third nuclear power plant is in the less important earthquake will happen area. Okay, then also it can increase the resistance of the construction. Okay, then maybe they are going to build more wide foundation and then a thick foundation and numbers of thick wall. Okay, and then it can reduce the impact of the seismic wave. Okay, and also if they are going to have a large earthquake, the whole reactor will be going to shut down immediately. Okay, and then after the earthquake, they will have to double check whether it's okay or not after it is going to reopen it. Okay, then I have said that in Taipei 101 we have installed a damper to reduce the seismic wave of the rock of the earthquake. Okay, then by installing the damper, it can reduce the the fluctuation and the vibration of the building itself. Okay, just like here you can see, it's a stimulation of earthquake, and then you can see if we are having a damper right here, then it can reduce. Somehow, while compared with others building, this one is more stable. Okay, more stable, isn't it? It's because the damper help to reduce the vibration of the whole building. Okay, but for here you can see. Let the boys help me to press the button to show the earthquake again. Okay, now you can see this one is more shaking. But if we are having a damper, it's not that shaking. It can reduce the vibration of the buildings. Okay, and then it is going to safeguard the whole building and then not that going to collapse that easily. Okay, and then 呢個咩嚟㗎 Let's see. Okay. Oh, then if we are going to put some vibration model this kind of thing. Okay, vibration reduction model, then it can reduce the impact of the earthquake as well. Okay, and you can see there's a lot of children. Okay, I'm not going to go with the children. Okay, and also we are not going to build a very tall building, and then the first story have a very good foundation, and then just like the Taipei building that I've just showed in the very beginning. 好嘈 Wait a minute. And then you can see the building right here. It is not going to have a lot of foundation, but if we are having a good foundation, then it will have fewer impact.